here's a quick review for the test dealing with chemical equations. So we have a chemical equation up here in front of us. This one is already balanced out, so we don't have to worry. But let's take a look at the parts of the equation. Well, there's always the beginning part. I like to call that the once upon a time. And in this case here, the name that we have for those are the reactants. Okay, those are the reactants. Now, you might want to think about that as the ingredients, much like if you're baking cookies, you have flour and sugar and chocolate chips, whatever it is, and then you mix them together. At the end, on the other side here, we have products. So that's what it would look like. We have reactants, what we're starting with, and products, what we're ending with. Now, in the thing here, we don't have it. You may notice we have an arrow, we never have an equal sign. Well, what's going on with the arrow? That means will result in, or this is what you're going to get. We don't say equals, that's nice for math, but in chem, we look at the arrow, we say this will result in. Okay, so some other things to look at. One of the things regarding the exam is balancing an equation. So, for example, if I were balancing, here I have oxygen plus hydrogen, and I end up with water. Okay, this is not too bad of a reaction to balance. Okay, so when we look at it, we want to make sure that we split this up into the two sides. That's a pretty important idea. Well, what are the two sides? This side will be our reactant, our ingredient, and this side will be our product. And you'd say, well, why does it matter about balancing the equations? Because we live in a universe where there is the law of conservation of matter. If I start out with 2 hydrogen atoms, I want 2 hydrogen atoms at the end of the reaction. If I want to start out with 2 oxygen atoms, I need to have 2 oxygen atoms at the end of the reaction. That's the law of conservation of matter. The numbers of each kind of element has to be equal on both sides of the arrow. That's why we have to do the balancing. So, with this, we're going to look at our 2 main things here. We're going to look at H and O. Ho-ho! It's far away from Christmas, I realize. So in this case here, we have 2 of these hydrogens, 2 of these oxygens, on this side 2 of these hydrogens, and 1 of these oxygens. Clearly it's not balanced. We're balanced for the hydrogens. Yay! We're not balanced for the oxygens, so we have to work with it. Now some people may be thinking, okay, let's go back. So some people may be thinking, well, if I put a 2 over here, that's going to balance it out, right? Yes, if you're looking at the number of hydrogens and oxygens, that would balance it out. Problem. And the problem is, when you're balancing your reactions, you cannot change the subscript. This is the subscript. If you change the subscript, you changed what it is. H2O2 isn't water, H2O2 is hydrogen peroxide, which when you have the full-on concentrated stuff will kill you. Not a good thing. So, how do we go about this? Well, I don't have to mess around with the hydrogens. They're balanced out. But I look at the oxygens. I've got 2 on this side, 1 on this side. Now, what number does 2 and 1 go into evenly? Oh, it would be 2. So the only thing I can do is put a 2 here. This is called a coefficient. That's the only thing you change when you're trying to balance out the reactions. So I have here 2 times 2 for hydrogen, so I got 4 hydrogens. Don't panic. Let's just work this through. 2 times 1 oxygen is 2. Okay? And we didn't do anything on this side here. We got 2 oxygens, 2 hydrogens. So we're balanced for the oxygens. Yay! We're not balanced for the hydrogens. Boo! So, how do we handle this? Well, we now got to work with balancing out our hydrogens. And this isn't too bad because we have 4 on this side, we have 2 on this side. How many of what number does 2 and 4 go into evenly? Well, they both go into 4 evenly. So 2 times what is going to get us 4 hydrogens? Oh, 2. So we can put a 2 up here. Remember, you changed the coefficient. So now let's bring this in. We have 2 oxygens, 2 times 2, 4 hydrogens. Okay, 2 times 2, 4 hydrogens. And then 2 times 1 is 2. Remember, the idea about balancing the equation is that you get the same number for the same element on both sides. It doesn't mean that there's going to be 4 oxygen and 4 hydrogen on each side. It works out that we have 4 hydrogens on each side, 2 oxygens on each side, and that's balanced. This is an example of a balanced reaction. Okay? And with that, ladies and gentlemen, we can put our happy face, because we are done with balancing. Okay? Now, what about some other things to look at? Well, we do have different types of reactions out there. And there's 4 main ones that we have to look at. One is the synthesis. The synthesis reaction, if you think about it, A plus B gets us AB. We're putting something together. This is a synthesis reaction. Okay? So we can look, for example, at our previous reaction here. A plus B gets us AB. That's a synthesis reaction. We were synthesizing water. Now, what about the other one? The next one would be decomposition. Decomposition, think breaking, taking apart. Think about your body digesting the food that you have eaten. It's breaking down stuff. So what would that look like? Well, we can go ahead and say AB breaks off into A plus B. This would be an example of a decomposition reaction. Now, how would that work for us? Well, let's take our water, for example, here. So we had our 2H2O, and we can break it down into 2H2 plus O2. So we have taken water and we decomposed it. Okay, it doesn't tell us how we decompose it. What do we need to do to decompose it? It just tells us, hey, look, if you're going to take water and you're going to tear it apart, this is what you're going to get out of it. Okay? So, moving on with the next one. Okay, we have what's known as a single replacement. That's the next one. A single replacement, ladies and gentlemen. Okay, you have A, B plus C gets us B plus AC. In other words, we switch out. There is a switch out, okay? No, blast. All right, hang on. It's Monday morning, I'm tired. Let me read. Here it is. One thing gets substituted for the other, and that's really what you're seeing here. Okay, that's a single replacement. I was thinking in terms of the order, but you're still getting the same thing. AB is one thing plus C. You get B kicked out and you get A and C together as one. This is a single replacement. Okay, our last one, ladies and gentlemen. Oh, and if you're wondering, real fast, let's take a look at a regular real-life equation. We did have one earlier, okay, where we had 2AgNO3 plus Cu gets us CuNO3 plus 2Ag. This is a real-life single replacement or single displacement reaction. That's what we have. I've got one more to go over with you guys, and then I'm done. And some people are saying, yes, let's take the test. Be careful what you wish for. All right. So double replacement. In double replacement, you have AB plus CD, okay? And we end up getting CB plus AD. And say, wait, how is that different from the single replacement? In the single replacement, you have one item by itself. Here you have two items together as an item. These two are an item. These two are an item. These two are an item, these two are an item. So what happened? The A switched places with the B and the D. It switched out. The C switched places with the D and the B. So that's what happened, ladies and gentlemen. This is a double replacement. So in double replacements, you have two things that are items, okay, and they switch out places. In single replacement, you have two things that are one item, and then you have one thing, and it's just switched out, like you see here. So that's it, ladies and gentlemen. Went a little bit longer than I had thought, but I'm hoping this will help you. God bless you and have a good day.